Hello everyone and welcome to Precalculus. This is section 7.3, Multivariable Linear Systems. So up until this point, we've only been dealing with equations that have just an x and a y. So maybe something like a line, or maybe something like a parabola. But these are two-dimensional figures. Now, let's say you took that parabola and then you brought it up into the sky, which of course I can't show you on the video, but it would make some kind of a three-dimensional figure. So a line where you add a whole nother dimension becomes a plane. And that's what an XYZ is going to do. Don't worry, we're not going to do it with parabolas. We're going to stick with planes. So what could happen with three different planes? Well, they could be parallel to each other, and then they wouldn't intersect at all. Maybe two of them are parallel, and one of them intersects both. That would also have no solutions, just like three parallel ones. But it is possible that they would all intersect, but along a certain line. This line is part of all three planes. Or maybe they intersect in such a way that they just meet at a point. Or maybe two of them intersect, but not all three, which would be another example of no solution. So we're going to do some problems that will show all these different cases. In order to do these problems, the key is to be organized. For me, I label all my problems A, B, and C. And then I'm going to use combination to put two of these equations together. And I'm going to label it so everybody knows what I've done. I'm going to put A and B together just by adding them up, because that'll eliminate my X. So when I do that, I have Y plus 3Z is equal to 5. Now I need to use equation C. That's mandatory because I haven't used it yet. But whether or not I use A or B next is completely up to you. So I'm going to use B, but I'm going to multiply it by 2. That way my x's will cancel again. So times 2, times 2, there's no z's, and then times 2. So I'm going to add these together, and the x's cancel, and I get y plus 5z is equal to 9. Now I can take those two equations and put them together. But if I put them together right now, nothing will cancel. So I'm going to do negative AB, which is negative y plus 3z, negative 3z equals negative 5. And then this one is just going to be c plus 2b, which is y plus 5z is equal to 9. Although, if you're not going to change an equation, you're welcome to just put an arrow showing that you're going to redo this one. I add them up, and I get 2z is equal to 4, so z is equal to 2. Now that I know z, I'm going to go back, and I'm going to plug it into here to find y. So y plus 5 times 2 is equal to 9. Y is equal to, that's 10, subtract from both sides, is negative 1. And now I'm going to go back here and plug in the y and the z. I can use any equation. So I'm just going to pick A. It's nice to label it, then everybody knows what you're picking. Minus 2 times, I just found out that y is negative 1. And earlier I found out that z is 2. And so now I can find x. X plus 2 plus 6 is equal to 9. X is equal to, this is 8, so 1. And then the last step is to express your answer as an ordered triple. And that is how you solve a system. Now I want to make a couple really important points on this. In addition to being super organized, if you label what you're doing each time, then it'll help me find any error that you might have made. I will look for your errors. There's a lot of steps to these problems, but not if your work isn't organized in a way that I can follow it. Second, It doesn't matter which variable you get rid of. So in this first one, we chose to get rid of x. That's fine. But once you make the decision to get rid of x, you have to get rid of x again. Because think about it, if this equation had been y's and z's, but this time I said, oh, it's easier to get rid of z, and this equation was x's and y's, then I couldn't have done this that I did. So once I get rid of an x on my first round, I have to get rid of x here so I can have equations with just y's and z's. Or if you get rid of z the first time, then you have to get rid of z the second time. And then there's 2 back steps. Once you find your first variable, go back 1 step to the equation with 2 to solve for that one, and then go back to the equation with 3. So the steps are very, very deliberate. And as long as you follow them, you'll really enjoy these kinds of problems. All right, let's do another one. On number 2, this one might look easier at a glance because it has less going on. But sometimes people really struggle when it's not x plus y minus 3z is equal to negative 1, and then some kind of x. So if it helps you, you could make it look like the more traditional problem by adding zeros to fill in the blanks. So if that format helps you, that's great. But either way, I'm going to label them A, B, and C, and then I need to put 2 together to get rid of something. So I can see right away that if I put A and C together, I can get rid of the x's. So A and C will give me 3y, and now this is 0z, but minus 3z is equal to 0. Now, because I got rid of the x, I have to get rid of the x again. Now, you could use b and some other equation, but look, b already has the x gone. So you can use b as your second equation. So on the one hand, this is harder because the format is new, but it worked out kind of nice, right? So I want to put these together. So I'm going to use AC, and then I'm going to use 3, actually negative 3b. So notice how I'm always labeling my work. So here's something that's interesting. I chose negative 3 because in my head I was thinking, oh, I'm going to get rid of the y's. But look what happened. I got rid of the z's also. So whenever this happens, all your variables cancel and you end up with a true equation. That means that there are an infinite number of solutions. But like in the last section, that doesn't mean that we can stop here. We have to actually find a representation for those infinite number of solutions. So once you get to this point, you're going to go back to the place where you had 2 things, just 2 variables, not 3. And you're going to use that to get 1 variable in terms of the other. So it doesn't matter which one you solve for. So I'm going to solve for y, and just by putting the z on the other side, y is equal to z. So now I can fill in part of my ordered triple. Y is equal to z. So I'm going to write a z there. Z gets to remain itself, and I still need to solve for x. So if these had been numbers, if you had, I don't know, 6 and 7, how would you find x? You'd plug it back into one of those equations. So that's what we're going to do. We're going to plug it back in. So I'm going to take this, and I'm going to go, if I went to A, then I would write x plus, and instead of y, I would write z. Minus 3z is equal to negative 1. That would give me x minus 2z is equal to negative 1. X is 2z minus 1. 2z minus 1. And what did that do for me? That gave me an entire problem, an entire ordered triple in terms of 1 variable. So now I could tell you one of the infinite solutions. If z is 0, then the y, which is equal to z, is also 0, and this would be negative 1. That is one of the infinite solutions. If z is 1, then the y is also 1 because it's also z. And then 2 minus 1 would be 1. That's one of the infinite solutions. And you could check any one of your infinite solutions back in the original to make sure that it actually worked. All right, let's try another one. Number 3. So my first step is always to label them A, B, and C. This one's set up more traditionally. I need to get rid of a variable. It doesn't really matter which one you choose, but let's choose Z this time. So B has a negative 2Z. So I'm going to write 2x minus y minus 2z is equal to 2. And it would be really easy for me to multiply A by 2. 2x minus 6y plus 2z is equal to 2. I like choosing something that I can multiply by a positive because you're less likely to make a mistake. That gives me 4x minus 7y, the z's canceled, which was my plan, is equal to 4. Now, I have to get rid of z again, so I can have two equations with just x's and y's, and I have to use c. I can alter c if I want to. I can do negative 2c or something, but I don't need to. 3z, but I can use either a or b. So I'm going to use a again, and I'm going to multiply it by 3. That'll give me 3x minus 9y plus 3z is equal to 3, which gives me 4x minus 7y. My z's canceled, and I got 2. So now I have, you can call it equation D and E if you want to. So I go to put D and E together, and I'm going to do negative E to cancel out my x's. So I have negative 4x plus 7y is equal to negative 2. Now my goal was to cancel out my x's, but my y's also canceled. So this is very similar to the problem that we just did, but there's one key difference. If you have a true equation, there are an infinite number of solutions. But if you have a false equation, then there is no solution, which is nice because now you're done. There is apparently these 3 planes. Remember, these are each a plane somewhere in space. So either they're parallel to each other, or maybe 2 of them intersect. My chances of drawing this are very bad. But then they don't intersect with the third one, okay? Or not in that same overlap area. But somehow they don't have any points in common. So the answer is no solution, and you'll recognize that because you'll get a false equation. Number 4. So again, I'm always going to start by labeling them A, B, C. I look for which variable I can get rid of the easiest. And I'm thinking it's going to be the x because I can use A to get rid of both B and C. So B is 2x plus 3y plus z is equal to 5. And I'm going to do negative 2a. So if I multiply this entire equation by negative 2, I get negative 2x minus 4y plus 14z is equal to positive 8. My x is canceled, and I got this. That's a positive 8, a little messy there. So now I have to get rid of x again, but I'm going to use equation C because I didn't use that one yet. I have to use it. So 3x plus 7y minus 36z is equal to negative 25. And since I have to get rid of the x's, I'm going to use the A equation again and multiply by negative 3 this time. See how organized my work is? Really makes a difference on these. So times 3 times 3 times, negative 3 and times negative 3 will give me negative 13 minus 15z plus y, and my x is canceled. So like I said, some people actually take the time to relabel these as D and E, and then you can put D and E together, and that would be positive y minus 15z is equal to negative 13. Everything cancels. So now I know that there are infinite solutions. If this is a 4-point problem, you've just earned 2 of them. You're only halfway there. I still actually want the answers. So the step is to go back to the place where you had 2 variables and get y by itself. So go back to an equation with 2 variables and solve for 1. That's going to be your first step. So of course I go to y minus 15z, I choose equation E, is equal to negative 13, and I get y is equal to 15z minus 13. Step 2 is going to be write your ordered triple. So now I know that y is 15z minus 13. That is y. I just told you that. And then fill this in as z. Z gets to stay what it is. One variable is going to get to stay what it is. And then step 3 is going to be use 2 points in the triple to find the third. So I personally am going to go back to equation A. Notice I'm labeling all my work. X plus 2, and what is y? I'm using the 2 points in my ordered triple. It's 15z minus 13. Minus 7z, z is z, so I can just leave it like that, is negative 4. So I get x plus 30z minus 26 minus 7z is equal to negative 4. X plus 23z, I'm going to subtract, add 26 to both sides, which is 22. And so x is equal to 22 minus 23z. And now I can fill that in. X is 22 minus 23z. So if you wanted to check this, you could say that, let's say z is 0, then y would be negative 13, and x would be 22. That is one of the infinite solutions that we're talking about here. If z is 1, then y would be 2, and x would be negative 1. If you're actually going to check back in an equation, like if I plug these into equation B, I wouldn't use the one with the 0, because 0 can mess things up and it can look right even when it's not. But 2 times negative 1 plus 3 times 2 plus 1 should be equal to 5. Negative 2 plus 6 plus 1, sure enough, is equal to 5. So you can feel very confident about your answer. All right, number 5. The height at time t of an object that is moving in a vertical line with constant acceleration is given by the position equation S. The height S is measured in feet, the acceleration A is measured in feet per second squared, t is measured in second, v sub 0 is the initial velocity, and s sub 0 is the initial height. So what we're going to do is we're going to find the values of A, v sub 0, and s sub 0, given 3 points that I know. Now, first of all, you might notice that this is a quadratic equation. So as a quadratic equation, I know it's going to make a parabola. And if I look at the data they gave me, at t is equal to 1, it has a height of 52. And then at t is equal to 2, it has a height of 52 again. And then at t is equal to 3, it has a height of 20. So it must look something like this, right? So that lets me know that A is going to be a negative number because this is a downward parabola. So let's see if we can find these. So first, I'm going to plug all these values, 1, 52, at 2, it's 52, and at 3, it's 20, into my equation. So first one, 52 is equal to 1/2 A 1 squared plus v sub 0 times 1 plus s sub 0. The second one, 52 again, is 1/2 a times 2 squared plus v sub 0 times 2 plus s sub 0. And 20 is equal to 1/2 a times 3 squared plus v sub 0 times 3 plus s sub 0. All right, let's simplify these. So I can rewrite this as 52 is equal to 1/2 a, and I'm just going to change these since there's no other v or other s to confuse it with. I'm going to temporarily eliminate this subscript there. And then this one I can rewrite as, oh, I don't know why I wrote 15. Sorry about that. 52. And this one I'm going to rewrite as 52 is equal to 2 squared is 4 times 1/2 is 2a plus 2v plus s. And my last one, 20, is equal to 9/2 a plus 3v plus s. And you know me, I really don't like to work with fractions. So believe it or not, before I even start, I'm going to change these one more time. I'm going to multiply through by 2, which gives me 104 is equal to a plus 2v plus 2s. This one I don't need to change. And on this last one, again, if I multiply through by 2 just to make my life easier, I'll have 40 is equal to 9a plus 6v plus 2s. So these are my equations A, B, and C. And now we're going to just solve the system like we normally would. I have to pick the variable that I think I can get rid of the easiest. So I'm thinking S, because then the most I'll ever have to do is multiply equation B by -2. So that's what I'm going to do. -2b will give me -104 is equal to -4a minus 4v minus 2s. I'm going to put that with equation A, which is 104 is equal to A plus 2v plus 2s. And that gives me 0 is equal to -3a minus 2v. Now I need another set of equations. So I have to use C. And again, I'm going to use -2b to cancel out my s's. So C is 40 is equal to 9a plus 6v plus 2s. And -2b is going to be just like last time. -104 is equal to -4a minus 4v minus 2s. So my s's cancel, and I get -64 is equal to 5a plus 2v. That worked out nice. I don't have to change either one of them. I can just add them together, and I get -64 is equal to 2a, and my v's cancel. So a is equal to -32. Once you get your first one, you can substitute that back into either of these equations. Let's just call them D and E. And then this is my DE combined statement here. So I can substitute that back in. -64 is equal to 5 times -32 plus 2v. So 5 times 32 is -160 plus 2v. So -64 plus 160 to both sides is 96. Well, that's still -64. -64. So 96 is equal to 2v. V is equal to 48. And this is actually v sub 0, which is meaning the initial velocity. And then once I have two of them, I can take two of them and substitute them into any equation. I choose equation B. So I'm going to put these into equation B, which is 52 is equal to 2 times A plus 2 times B V plus S, and that's how I'm going to get my S. So this is 52 is equal to negative 64 plus 96. 52 is equal to 96 minus 64 is 32 plus S is equal to 20. Whew, that was a lot of work. Good job. They do have units. S is measured in feet. It's the original height. The velocity is measured in feet per second. And the acceleration is in feet per second squared. Number 6. Find a quadratic equation y is equal to ax squared plus bx plus c that passes through the point negative 1, 3, 1, 1, and 2, 6. So I can picture this, negative 1, 3, 1, 1, and 2, 6. So I don't know, maybe something like that? I'm not really sure, but I think A is going to come out to be positive. I think that's the only way I can really draw it, even though it might not be exactly right. So same exact process as last time, but without all the word problem part. So 3 is equal to A times negative 1 squared plus B times negative 1 plus C. 1 is equal to A times 1 squared plus B times 1 plus C. And 6 is equal to A times 2 squared plus B times 2 plus C. And you're really going to want to simplify all of these equations before you actually start. So 3 is equal to A minus B plus C. 1 is equal to A plus B plus C. And 6 is equal to 4A plus 2B plus C. And now I have a system of equations that I can solve. However, instead of doing another one for you, I'm going to show you how you could do this on your graphing calculator. So your calculator has the ability to find a quadratic equation based on the points that you give it, and it's called a regression. To do a quadratic regression, the first button that you're going to want to push is the stat button right there. It always highlights it in red in case you didn't realize that. And then we're going to edit our lists. So our list is very short. You're going to put the x coordinate in the L1 and the y coordinate in L2. So negative 1, and then 1, and then 2, and the corresponding y coordinates are going to be 3, and then 1, and then 6. So once you have all your data in there, you're going to hit the stat button again. And this time you want to do a calculation. So you're going to tab over to calculate, and you literally go down to quadratic regression. That's what it's called. You can either hit the number 5 or you can arrow down. And it says, is the X list in L1? Which we did put it there, and we put our Y list in L2. Don't worry about the other things. You can just go right down to calculate and hit enter. And look at that. This is a beautiful thing. It gave you A, it gave you B, and it gave you C. Now, C looks a little funny. This is actually negative 8.8 times 10 to the negative 13. So it means it's really close to 0, but not exactly 0. But for our purposes, we're going to record that as 0. So without even solving this, my calculator told me that A was 2, and that B was negative 1, and C, for all intents and purposes, was 0. It was something times 10 to the negative 13, which is 0.0000000. So it's pretty much 0. So y is equal to a x squared plus b x plus c, which of course we wouldn't actually write it like that. Y is equal to 2x squared minus x. So if you liked that and understood it, you actually could use that for a problem like this. Look at all that work we did. Wasn't that horrible? You could literally perform a regression, type those 3 points in, do the regression. Is it worth knowing? Absolutely. So you might want to go back and practice a regression on this one and see if you can get these three answers by doing it on your calculator. All right, number 7. An inheritance of $12,000 was invested among 3 funds: a money market fund that paid 5% annually, municipal bonds that paid 6% annually, and mutual funds that paid 12% annually. By the way, if you're wondering, why would somebody not just put all their money into mutual funds? Some things are safer than others. So bonds are extremely safe. So even if the stock market changes and the mutual funds actually don't pay 12%, that you wouldn't lose all your money. So it's called diversification. It is important to know for when you guys grow up. All right, so the amount invested in mutual funds was $4,000 more than the amount invested in municipal bonds. The total interest earned during the first year was $1,120. How much was invested in each type of fund? So remember, use the question to make your variables. So X is the dollars invested in the money market. I could have used M, but honestly, municipal bonds, mutual funds, they all have M's, so I'm just going to stick with X, Y, and Z. Y is the money invested in bonds, and Z is the money invested in mutual funds. So use the question to define your variables. And now we need to write our equations. So the first piece of information is that 12,000 was invested. There we go. X plus Y plus Z is 12,000. That's how much money you invested altogether. And then it says how much each paid. So you have to put 2 pieces of information together. How much percent interest each paid, and then how much the interest actually was. So however much you invested in the money market, you got 5% in interest. So 0.05 of X will give you the interest from the money market account. If you add that to the interest you get from the municipal bonds, and then you add that to the interest you get from your mutual funds, apparently after a year, you got $1,120 in interest. So that's the hard one. That's your next equation. And then the last thing that they said was that they invested $4,000 more in the mutual funds than in the municipal bonds. So I will just tell you right now, this is where most people go wrong. Watch out. They write this backwards all the time. So if you need to, give yourself an actual example. So if the mutual funds was, let's say, 5,000, then that needs to be 4,000 more than the bonds. So the bonds would have to be 1,000. So if this is Z and this is Y, what's the relationship between them? Y plus 4 is equal to Z. Y plus 4,000 is equal to Z. So really easy to get that backwards. So give yourself, or if you want to, instead of doing it this way, just write which way you think it is and then try 2 numbers. Okay, so if I put $1,000 in the bonds, I'd be putting in 5,000 in mutual funds. Yes, that's correct. But don't get that backwards. Okay, so you have a system of 3 equations. We can't do this the way we did on the calculator. So you're back to just solving a system. So we already have an equation with just Y's and Z's. So I'm going to do 2 things to make this simpler. Number 1, I'm going to rewrite them, and I'm going to multiply that second equation by 100. That way I have 5x by 100. That way I have 5x plus 6y plus 12z is equal to 1, 1, 2, 0, and then 2 more zeros. That's what happens when you multiply by 100. And then the last one, I'm going to move the y over with the z. So negative y plus z is equal to 4,000. Looks nicer, doesn't it? And now you can see that if you call these a, b, and c, I already have an equation with just two variables. So if I put a and b together and get rid of the x's, then I could have another equation with just y's and z's. So negative 5 times a. That's what I'm going to do to this equation. So that gives me negative 5x minus 5y minus 5z is equal to negative 60,000. And then I put that with b, which is 5x plus 6y plus 12z to z is equal to 112,000. And then when I add those up, I get y plus 7z is equal to 112 minus 60, which is 52,000. So let's call this equation D. Now, oh, I don't have to do anything to them because this already is a negative y and a positive y. So you didn't have to label it D. You can just put them together. If you add them together, you get 8z is equal to 56,000. So 56,000 divided by 8 is 7,000. So apparently you're putting 7,000 into your mutual funds. Then I take this and I go back a step. So, or either one, negative y plus 7,000 is equal to 4,000. So negative y is equal to negative 3,000. Y is equal to 3,000. And then finally, you're going to take the 2 that you've learned and you're going to pick one of the 3 equations. Actually, that's not true. I can't pick C because it doesn't have any x's in it. So obviously I pick A, x plus y plus z is equal to 12,000. So that's 10, so x must be 2,000. It is a word problem, so make sure that you don't stop there and just box this answer. You do not want to do that. Instead, you want to write it as, you should invest. I know this is a pain, but it's real life. You should invest 2,000. You can take that shortcut. That's real life. 2,000 in the money market account. 3,000 in the bonds. You don't have to say municipal bonds. And 7,000 in the mutual funds. That's what the answer should look like. Okay, so hopefully that gave you a good sense of how to solve systems of equations. Our last section is definitely going to be a little bit of a challenge, but you're smart, you can do this. So far all the systems we've been solving have been square, which means that the number of equations is equal to the number of variables. In a non-square system, the number of equations differs from the number of variables. These problems cannot be solved for a unique solution, but you can write the answers in a form similar to the one we use for infinite solutions. So I mostly like to practice these because it helps you understand how to do the ones where the answers are things like a plus 1, 2a minus 3, things like that. So it's good practice for that. So I just need to pick a variable and get rid of it. I can get rid of z super easy. So a and b together is going to give me 3x minus 3y is equal to 3. So I can't actually, I have nothing else to put together to get x and y alone, so I'm done. I'm going to divide everything through by 3, and then I'm going to solve for one of my variables. So x is equal to y plus 1. So x is, think about how you say this, x is y plus 1. So x is y plus 1. So since y is clearly the variable you're going to use to write your ordered triple, y gets to stay y. since y is what you used, y gets to stay y. People really struggle with that. Y gets to stay y. One variable gets to stay what it is. And then z has to be in terms of y. So you're going to take any one of these equations and you're going to plug everything in. So x is now y plus 1. Y is still y, but z needs to be in terms of y. Solve for z. So this gives me, I'm going to subtract 1 from both sides, and I'm going to combine those. So negative y plus z is equal to 1. Z is equal to y plus 1. So z is also y plus 1. What that means is that this plane and the other plane intersect, but not everywhere. There are an infinite number of solutions, but not every ordered triple is a solution. Only ones that follow this pattern. So 4, 3, 4, 201, 200, 201. I could plug any of these ordered triples in, 11, 10, 11, and any of these ordered triples should work in there. All right, let's try one more of those. X minus y plus 4z is equal to 3, and 4x minus z is equal to 0. I already have one that's just 2. So I'm going to get z all by itself. 4x is equal to z. So z is 4x. So clearly on this one, I'm getting everything in terms of x because I chose to make z 4x. So what's the variable that gets to keep its own name, that gets to stay itself? X, because all three must use the same variable. So since it was easiest to say what z was, z is 4x, x gets to keep its name. So what do I need still? I need y in terms of x. So I'm going to have x minus y plus 4z, and z is 4x, is equal to 3. So x, I'm going to actually add the y to the other side, plus 16x is equal to y plus 3. And then I'm going to subtract 3. 17x minus 3 is equal to y. So 17x minus 3. So what's an example of an answer? 1, 14, 4. If I tried that combination in here, it would work. So if I call this A and B, if I put that in equation A, 1 minus 14 plus 16 should be 3. And is it 17? Yep. So now I know my ordered triple is correct because I checked a point and it worked. So these are not required. I'm not going to give you one this hard on a test or a quiz in CP, but it does let you get a little extra practice on this weird last step, which people do have trouble with on systems of equations. All right, that is it for 7.3. Have a great day.